All right, chapter 4, we're going to talk about control statements. We're going to talk about if, ands, ors, and nots, switches, whiles, do's, fors. We're going to talk about loop and how you compare the difference, what type of loop you're going to use. We're going to talk about nested loops, Boolean variables, input validation, Boolean logic expressions. All right, y'all are familiar with the conditional statements that we talked about, right? If whatever this condition is, then you can do this. Each loop, or each type of loop, is also going to have a condition. I'll get it later. While this condition is true, do this. Okay? Now, what is a condition? Anyone know?
Temperature.
No. A condition, what does it measure? It compares two objects, right? That's the comparison part. So, in Java, we have a couple different types of comparison operators. We have a double equal. Why is it double equal instead of just a single equal? Anyone know?
Because a single equal is an assignment operator.
A single equal is an assignment operator. That means you're assigning this value to this. If you're going to compare it, you have to use two equal signs. Pretty simple. Yes?
I think you need to use 3 too.
No. Just two. The not equal to, which is your exclamation point, my less than, greater than, or less than and equal to, or greater than and equal to. All right? Those are comparisons. Each comparison operator will evaluate to a Boolean variable, whether it's true or false. Correct? Denny has on a gray shirt. Right? Is that true or false?
I don't know. Can't see.
Denny, is it true or false?
It's true.
Okay. So then that loop or whatever that function would be based on that true statement with an object. So, for an example, 3 with two equal signs, 3, is that a true statement? 3 equals 3, right? 3 equals 4. Is that false? So you'd have a false statement. Remember, always remember when you're doing the comparison that you have the two equal signs. Not equal. It checks for the inequality of the individual. All right, let's see here. What can I use? Cody and Matthew have the same color hair. Or what you do is say, Matthew's hair not equal to Cody's hair. Is that true or false?
True.
It's true. It will always be true because none of us have the same hair, right? We may have the same hair color, but not necessarily all the same style or same cut or anything like that. Except for those celebrity twins that you always hear about. I think they just seem to look enough alike they decided to do their hair that way. And then the less than, equal to, less than, greater than, or greater than, equal to. All of those operators work the exact same way as the not. They all do a comparison. You have one object, you compare it with the other object. Pretty simple. So, we talked a little bit previously about the if statement, right? I did that last chapter. So we have an it by itself, means if you're going to do this step, then if this condition is met, then you will do this. That's all it means. And if it doesn't meet that condition, then you just go on the rest of the program. If you have an if-else, now you have a choice of which one you're going to do. Or if you have an if-else-if, you have 3 or more choices. Does that make sense? If statement is 1, if-else is 2, if-else-if is 3 or more. And we've seen this before, right? Where you have your if and a condition and it just prints a statement. And if it's not, then it just goes on to the next one and skips printing that statement or do whatever it says. If else, you have your if, prints that statement, else it's going to print that statement. If else if is just the nested version of it.
I have a question. I've seen somewhere, I can't remember the iChain where you have the 3 horizontal lines, one over on top of each other.
Mm-hmm.
What is that?
We'll get to it.
Okay.
Okay, write a complete program that will prompt the user to enter a sentence and then print its error message. The last character is not a period. In this case, the permanent good can never be the outcome of violence. That's going to be our inputted statement. Okay? Why? What are we checking for? If input has a period.
Right.
Right? If it doesn't, you put this. If it does, you just go on. Let it run. Make sense?
What if there's a period in the middle?
It has a period, right?
Okay.
Your sentence needs a period.
Well,
You could look at the, let's just call this sentence dot length. You could look at find out what that length amount is, then go to the character at and see if it equals to a period. So if you say the variable would be, in this case you could say, we'll call it S is going to be the sentence dot length. So I'm assigning S to this. And then I'm going to say on my condition, if S not equal to I'm sorry. If, how shall I put this? It would be,
char at.
it's going to be S dot char at, well, it'll be, sorry, sent dot char at S, or whatever we name this variable. So that we're looking for that specific spot to equal this. And if it doesn't, then we have a false statement, right? Well, it would be a true statement if there's not there. And then we'd print out the invalid entry, your sentence needs a period. Right? Remember, we've done the logical operators. If the temperature is greater than or equal to 50 and less than or equal to 90, print OK, else print not OK. See how you did a double condition? The problem with this is you can't use and. It has to be ampersand. The double ampersand, because that's a condition. But this is just the pseudocode version. Okay? So if temp is greater than 50 and temp is less than 90, print OK, else to that. This would be something you might want to look at. I was nice enough to give you pieces of information for you to look at in the content area, right, Lee? The program on the next slide determines whether fans of basketball game win free French fries. If the home team wins and scores at least 100 points, then the program writes a message. Fans, redeem your ticket stub for a free order of French fries at Yummy Burgers. Okay? Let's insert a code here. So we've read it in. Ask them how many home team points and how many visiting team points. So what would we write here? It read in the opponent's points, or I mean the home team points. So if home points is greater than or equal to 100, then print the statement, right? That's simple. Anyone not catch that? Don't be shy. Provide code that prints by if a response variable contains a lowercase or an uppercase Q for quit. So if response equals Q or Q, print by. So all you do is if response, meaning that's the variable, is going to equal a Q with the OR operator, which is the two pipe symbols, response equals uppercase Q, Or if you really wanted to have fun with it, you could do a response equals, but you have ignore case in front of it, make it an ignore case function with the response dot equals q. And so you wouldn't have to do the or that because it would say either uppercase or lowercase. Print by. But we'll get to ignore case a little bit later on.
Can you do quote, or little q, quote, space, and then the big quote with the
Nope,
or
that's it.
separator between it?
Nope, has to be just like that.
Okay.
If you're gonna write it, if you're gonna write like this without the ignore case. Logical operator of or. All it does, if you have a true or a false, what's your result gonna be?
Well, if it's true, then by. If it's not.
No. If you have two conditions, if you have a Q or a Q, what will you have?
True. True. That's an or, right?
It will be a true because you have one that matched it. What about a true and a false?
Well, that's what I was asking right there. Can we do that?
Yes. I thought you were just talking about response equals this, close, or.
No, like that.
I thought you were just meaning remove this response equals there.
No.
No, you can't do it that way. Because your response is going to equal this, or this, or this, or this, or this. Basically, it makes it a case statement. So, what if I did an and? Anyone answer my question? If a true and false,
Well, that would be.
that would be a false.
Can you do that? Because that says it generates an error if you don't repeat the variable name.
Oh, right here?
Yeah.
Yeah, that would be right. That's why I was saying earlier you had to do it this way.
Okay.
Yeah, you can't do it this way because you have to have that response dot equals. You can't have, even though it'll compile like this because you're doing this or this, it would have to end here to make it actually function. It'll compile because these are correct compile statements, but it won't work. All right, here's that ignore case. Response equals ignore case Q. So it'll check upper or lower. That's all you have to do right here. All right. The not operator. What does it mean?
Not.
It does the opposite of what you want. Switch statement. It's actually what we call, their switch statement is what we call a case statement. Switch, and you give a condition. The output of that condition will be the case. So, how shall I do it? Please enter a number 1 to 10. Switch number. Okay. Case that number equals 1, comma 2, comma 3. Do this. Break. Whether it's 3, 4, 5, or 6. Break. And then until as many as you want. Else, if it doesn't match that 1 through 10 in that case, then it does the default and say you did not enter valid. Default on a case statement is not necessarily your escape, but it allows the case to complete and go on and lets people know if there's an error or if it didn't meet your condition or any of the previous cases. Does everyone understand what a case statement is? How many of you do not? Cody? Okay. Just want to make sure. All a case statement is, actually it wouldn't be this. I'm just using this as what the variable would have inputted. Okay. Case Lee saw my name is Lee. Case Cody all it is, except I would have a variable name up here instead of where I have these strings. I'm trying to simplify it for you. User inputted Cody. Well, it goes to the first one. Case Lee. Is it Lee? No. Case Cody. Yes. So I'm going to do a system out print line. My name is Cody. If this was Scott, is it Lee? No. Is it Cody? No. Comes to the default. My name is not Cody or Lee.
So that makes sense.
It's similar to, very similar to an if statement. But instead of having only this one condition met, I could say or I could have multiple condition answers. Because it's looking here at cases, what answers are there to that variable or that condition. Does that make more sense now? I could have 1,500 of them out here if I wanted to. So if it matches any of that criteria, then it does this. Else it goes to the next case. Does it fit in that case? If it does, great. Then it prints that out. If not, then it does it. And of course, to be syntactic.
Tactically. Is that what you're trying to say?
You would want to put in breaks to make sure your syntax is correct.
Is the break in after default or
No,
no?
it's just on the end of the statement. You have your semicolon, you're done. I just put it up there for the fun of it, just to simplify it, to show you that you have it essentially breaks that switch statement. Everyone okay with that? A switch statement, all it does is jump to that case that matches up with that constant, which is whatever that variable that we're looking at, okay? If that value for that case is matched up with any of those case statement, or the constant matches up with any of those cases, then it does what's in that case. Else, it goes to default, and then whatever default tells it to do. Break statement basically allows it to jump out of the case so that if I'm right here and I'm either Lee or Denny, if I didn't have this break, it would go down here, case Cody. Break just says, okay, I've met this. Now I can leave this switch statement. I no longer have to do anything in here. That's all that break means. Yes, Lee.
Is there a limit to the number of cases you can
No.
use?
It's infinite. It's like an if else if. Just a different way of writing it, and you can have more. Come on, I think my battery's running out on this. You have more chances to do things. Okay.
So I use mine.
No, I'm fine. I don't really use it that much. To use after each case name, like case right here, I put in a semicolon or a colon to identify that as a case, and then give what case I need. And your constants are always going to be within a brace, just like this. Switch I, I'd open it and close it, and I'd print everything out case 1, case 2, case 3, case 4, case 5, so forth, so on. All right. And in this case, if they print out a 1, 2, 3, if I put input 1, what's going to be my output?
A.
If I input a 4, what's my output?
CD.
If I input a 5, Easy Rider, right? Okay. On your own, I want you to practice writing a case statement for this. All right. So remember slide 21, you'll write your own case statement on. Or your own switch statement. Your helpful hint is going to be on slide 20. Okay? Any questions? Okay. Now let's talk about the while loop. While a condition is true, the loop is going to continue until you change inside that loop. If user input is not a Q for quit, then it'll continue the thing, and you ask them every time, would you like to quit? Press Q to quit. If they push anything else, they go through the loop again. All right? Pretty simple. You have to, when you have a while, in order to terminate this condition, the condition has to become false. All right? Or you can set a while to be a not false statement, and so once they give a true value, then it'll be done. Does that make sense? You hardly ever see a not false value or not true value, so it has to be a false value.
Do you recommend using reverse logic or?
Regular logic. It's a lot easier for most programmers. Public static void main strings args, right? We're going to write a main method that finds the sum of user integers where negative 99,999 is a sentinel value. What is the sentinel value?
Counter.
Negative 99999 is what's going to allow you to escape. Okay, sequential means it goes to the next step. So you either type Q, or you have to type negative 99,999 in order to exit. And all it's doing is saying X, the value of X, is going to take the sum and it's going to keep adding it. Whatever they added in here. So if I say add an integer, you give me 10, so X is going to be 10. So sum is now going to equal 10, because sum is 0, X is 10, sum is 10. Enter an integer, 100. Well, now it comes back because it wasn't 99,999 negative, right? So now I'm at 110. Enter an integer. And then once it's done, then it'll print out and say the sum that you entered was whatever. Makes sense? Denny, you have that crazy look on your face like you didn't get it? Oh, okay. A do while. The difference between a while or a while and a do while is that a do while will go through at least once. You do all this while the condition is true. So it's good. Remember, programs just go straight down logic, and then it gets to the while and says, "Oh, do I meet the condition? No." Then I'm going to come back up here to the do. So we'll go through that loop the first time. Okay. You have to put a semicolon here after the do while. Now, if you forget your braces here, it will not compile, because then you have a do statement that wasn't completed, and it'll read this as the next while statement. All right. Problem description. As part of an architectural design program, write a main method that prompts the user to enter the length and width of dimensions for each room in a proposed house so that the total floor space can be calculated for the entire house. After each length and width entry, ask the user if there are any more rooms. Print the total floor space. Y'all know how to do that? Do while. So in the do while, we're going to come in and say, first room, what's the length? What's the width? Do a calculation, say area. And then let's say it's 10 by 10, so it's 100 square feet, right? So the area is now 100. Add that area calculation to the total area, so that when you come up to the next time and it comes through, enter the next room, then area gets it, and then it adds it back into the total. So at the end of the thing, you can say your total square footage is, and then you can also say rooms, so anytime you do an iteration through that loop, you're counting it. Does that make sense? Like x plus plus, so you once it goes through the first one, find x is 0 to start with, and then x plus plus at the end of that loop, so that you know how many rooms. You have 3 bedrooms or 3 rooms with a total square footage of such and such square footage. Make sense? When do you use a for loop? When you know for a fact how many time, what your countdown is going to be, or how many loop iterations you're going to use. If you don't know, you're going to use a do while or just a while loop. I always use a while. I don't ever do with the do while. Unless I know it's only going to do it one time. Then I just write it straight out and I don't worry about a do while. Alright. Let's find the factorial of a user entered number. The number is 4. What does it mean? While x is not 0, you take x times, in this case, it'll be x times x minus 1, and you keep doing that. And then after that, you go x minus minus so that the value of x goes down. Does that make sense? Yes.
Start that code out with the variable already hard coded where it's not input and then it just counts down.
Oh, this is just a printing countdown. So it'd be for x equals 0, x is less than 10, or x is less than 11, x plus plus, print x, or I'm sorry, x minus minus, print x. All right. Right here. Here's that liftoff program. With the exception it's not, yeah, it's going to do that. Print out the variable in like 10, 9, 8, 7, 6. Remember, before the first loop iteration, you're going to execute the initialization statement, which is your integer equals 10. Then it's going to evaluate it. Is I greater than 0? Then it's going to, if that's true, then it's going to start doing the loop. But after the loop is done, it'll take 1 less off of I. Does that make sense? That's all the for loop does. And again, here's a for loop. I equals 2, I is less than or equal to number. Number was what was read in. If it's not, then your number factorial won't work. Oh, I'm sorry. I is going to start with 2. So factorial is times equal I. And that's how it'll come out to be. Well, I is less than or equal to number. Interesting. Because if it's 2, it'd be 2 to 2, which would be fine. 3. Oh, I see what they're doing. Okay. I'm not going to have you do that one. Loop comparisons. For loop. If you know how many you need to go through, you'll do the for loop. If you need to do it at least once, do the do. And if you if you can't use either one of the previous, use a while. Everyone okay with that? Nested loops. What are nested loops? Simple. They're a loop within inside of a loop. How do you build a two-dimensional array? 2 for loops stacked or nested. Okay? That's all it is. So when you start getting into chapter 9 and 10, when you start talking about arrays, if you take advanced Java, you're going to have a lot of nested loops. That's where you're going to start seeing them, okay? Boolean variables. Remember, a Boolean variable, all I can do is true or false. Pretty simple. Boolean variable holds the value of either true or false. Garage door, is it up or down? If it's up, it's true. If it's down, it's false. If it's in the up direction. Does that make sense? The variable name is up direction. You want to say if it's up, then it'll be true. If not, then it's false. That's a Boolean variable for you. Do, up direction, is checking inside of up direction until it's not equal to up direction. All right. Garage door opener simulator. And this is all it is. Is it moving up? Is it moving down? Or else it's stopped. In motion, it's not in motion. If it's up, moving up. Else, moving down. If it's not in either one of these, then it's going to be stopped. But here's the crazy thing. If up direction is a false, then it would print moving down, but if it's still in motion, would it not? What do you think about that logic? You'll see it? If it's in motion, then it does this. Else, it's going to do this. Y'all see that, right? This is a nested if. If in motion is false, it's going to jump down here. If it's true, it's going to say whether it's going up or down. Does it make sense? Like I said, Boolean variables can also be used to check users' inputs to see if they're valid inputs or not. That's what we call input validation. Valid entry is false. Do. If entry equals nothing, or it's a Q, it's a valid entry. We're going to set it to true. Else, we're going to say it's an invalid entry. So if you hit an A, Is that the enter key or the Q? Then it would be false, right? So it would be an invalid entry. Boolean logic is a formal logic that determines how the conditions are evaluated by using ands, ors, or nots. All right. X not equal to 6.5 or not okay. Excuse me. So what is this going to evaluate to? Is X not equal to 6.5? Look at it. Is X not equal to 6.5?
It's true.
Well, it says above that X does equal 6.5.
So that would make that a false statement, or not okay, which would be true, right? So you have false or true, so that would be a true statement. True and 12.0 is less than X plus Y. Well, what's the first thing you do?
Well, you got 16.5.
No. Think about your logical operations.
Well,
What's your order of precedence?
Goes true and below, and then less than X. Or
Here's your hint. Your X plus Y will be the first thing you do, because it's your first mathematical operation. Then you have conditions. This is more of a mathematical comparison, right? So it's more of your mathematical idea. So 12 or 16.5 is greater than 12, right? So if I have true and true, my answer is true. Which Java loop statement has 3 components in its heading? For loop.
that's C.
Any questions?